Mars is a planet. It is our neighbor in the vastness of space. It is the fourth planet from our star, the Sun. Earth, our home, is the third planet. This means Mars is a little farther from the Sun than we are. It travels in its own orbit, a path around the Sun. Mars is a truly fascinating world, a place of mystery and discovery. Many people look up at the night sky and wonder about Mars. We are learning more about it all the time, thanks to science and exploration. It beckons us to learn its secrets. Why do we call Mars the red planet? It's a good question. Mars looks red even when you see it from Earth without a telescope. This unique color comes from its surface. The ground on Mars has a lot of iron minerals. Over billions of years, this iron has rusted. Think of an old bicycle left out in the rain. That rust is iron oxide. This rusty dust covers almost everything on Mars. So, Mars is like a big, rusty, dusty desert in the sky. It's a very special and striking color for a planet in our solar system. Mars is smaller than our Earth. It's about half the size of Earth if you measure it across. If Earth were a basketball, Mars would be like a softball. A day on Mars is surprisingly similar to a day here. It takes about 24.6 Earth hours for Mars to spin around once. We call a Martian day a sol. This helps scientists keep track of time there. However, a year on Mars is much longer than an Earth year. It takes Mars 687 Earth days to complete one trip around the Sun. That's almost 2 of our years. Mars is not alone as it journeys through space. It has 2 very small moons. Their names are Phobos and Deimos. In mythology, these names mean fear and panic, fitting companions for a planet named after the Roman god of war. These moons are not round and smooth like our moon. They look more like lumpy potatoes or captured asteroids. In fact, many scientists believe that's exactly what they are. They think Mars's gravity snagged these space rocks long ago. They are tiny compared to Earth's large, familiar moon. The surface of Mars is a place of stark beauty and extreme conditions. It is a cold desert world covered in rocks, sand, and that famous red dust. This dust is very fine, like talcum powder, and it gets everywhere. Sometimes strong winds on Mars can whip up this dust into enormous dust storms. These storms can be so big that they cover the entire planet for weeks. Imagine a single storm cloud engulfing your whole world. It's very different from Earth's weather patterns. We also see many craters on Mars, scars left by impacts from asteroids and comets over billions of years. Mars is home to some truly colossal features. It boasts the largest volcano in our entire solar system. This giant is called Olympus Mons. It's a shield volcano, meaning it's very wide with gently sloping sides, not steep like a cone. Olympus Mons is an astonishing 3 times taller than Mount Everest, Earth's highest peak. That's incredibly tall. It's so vast that if you were standing on its slopes, you wouldn't even realize you were on a mountain because the curve would be so gradual. Scientists study it to understand the volcanic history of Mars. It has not erupted for a very long time. As if a giant volcano wasn't enough, Mars also has a gigantic canyon system. This system is called Valles Marineris, named after the Mariner 9 spacecraft that discovered it. This canyon is super long and incredibly deep. It's many times longer and deeper than the Grand Canyon on Earth. Valles Marineris would stretch all the way across the continental United States, from New York to California. Imagine standing on the edge and looking down into that vast chasm. It was likely formed not by a river, but by tectonic plates cracking and pulling the crust apart billions of years ago. What about the air on Mars? We call that the atmosphere. The atmosphere on Mars is very, very thin. It's about 100 times thinner than Earth's atmosphere at sea level. It is mostly made of carbon dioxide, which is the gas we humans breathe out. Plants on Earth use carbon dioxide, but we cannot breathe Martian air. The thinness of its atmosphere also means Mars doesn't hold on to heat very well, and it doesn't offer much protection from the sun's radiation. This is one reason why the surface of Mars gets very, very cold, especially at night. Scientists are incredibly curious about Mars. It's one of the most explored celestial bodies in our solar system, after our own moon. Why all this intense interest and investigation? One of the biggest reasons is the quest for water. We know that here on Earth, water is absolutely essential for life as we understand it, so scientists search diligently for signs of water on Mars, both past and present. Finding evidence of stable liquid water could mean that Mars was once, or perhaps still is, capable of supporting life. This search drives much of our exploration. So did Mars have flowing water in its ancient past? The evidence strongly suggests yes. Our robotic explorers have sent back amazing pictures. We see features that look exactly like dry riverbeds on Mars. There are also ancient deltas, where rivers might have emptied into larger bodies of water. We see what appear to be shorelines of ancient lakes or even oceans. Furthermore, Mars has polar ice caps, much like Earth. These caps are made of a mixture of water, ice, and frozen carbon dioxide, or dry ice. This means water was, and in frozen form still is, present on the red planet. This leads to one of the biggest questions in science. Could there be life on Mars, or could life have existed there long ago? This is a profound question, and scientists don't have a definitive answer yet. If Mars had liquid water on its surface for extended periods in its past, then perhaps simple, tiny life forms could have emerged. These would likely be microorganisms like bacteria, very small and basic. They might be long gone, or perhaps some hardy microbes still survive, hidden underground where conditions are more stable. The search for these ancient or present biosignatures continues with every mission. Mars is quite different from Earth in several key ways that impact habitability. Its thin atmosphere doesn't protect the surface from harmful solar and cosmic radiation as effectively as Earth's thicker blanket of air. There is currently no large-scale liquid water flowing on the Martian surface because the atmospheric pressure is too low and it's too cold. On average, Mars is much colder than Earth. These significant differences make it a challenging environment for life as we know it to thrive on the surface today. But perhaps Martian life, if it ever existed, was different and adapted to those conditions. How do we learn all these fascinating things about Mars when it's so far away? We send robotic explorers. These amazing machines are like our scientific scouts, sent on long journeys through space. Many missions, launched by different countries, have successfully traveled to Mars. Some of these spacecraft are orbiters. They circle Mars from above, taking detailed pictures, mapping the surface and studying the atmosphere. Others are landers and rovers, which touch down on the Martian surface to get a close-up look and analyze rocks and soil. These robots are our eyes, ears, and hands on the red planet. You might have heard the names of some famous Mars rovers. Spirit and Opportunity were twin rovers that explored Mars for many years, far exceeding their original mission plans. They found compelling evidence of past water. The Curiosity rover, a car-sized mobile laboratory, is still working hard today. It has made incredible discoveries about ancient Martian environments that could have supported microbial life. More recently, the Perseverance rover landed. Its main job is to search for signs of ancient microbial life. It's even collecting rock samples that a future mission might bring back to Earth for detailed study. These rovers are true robotic pioneers. What are the future plans for exploring the red planet? Scientists and engineers are always dreaming up new and more advanced robotic missions. They want to explore new regions, drill deeper and analyze samples with even more sophisticated instruments. Beyond robots, there is a grand, long-term goal: sending humans to Mars. This would be an incredibly challenging and historic journey. It would take many months for astronauts to travel there. They would need a special spacecraft and a habitat on Mars to live and work. It's a huge undertaking, but it's an exciting goal for humanity. Why is understanding Mars so important for us? Studying Mars helps us learn about planets in general, including our own. It teaches us how planets form, how they change over time, and what makes a planet habitable. Comparing Mars to Earth can help us understand Earth's own past climate and its potential future. And of course, if we were to find evidence of past or present life on Mars, it would be one of the most profound discoveries in human history. It would change our understanding of our place in the universe. Mars is a crucial stepping stone for future human exploration deeper into the cosmos. It holds keys to our past and inspiration for our future.